Now we've seen what an image looks like in TensorForm, let's build this little function that's going to do these steps here. So what we might do is just copy them so we can see them down below. And I'm going to just write a little cell here. Now we've seen what an image looks like as a tensor. Let's make a function to pre-process them. Alrighty. And so, what we might do is define a variable here, image size 224. And you might be wondering, like I always do when I see things like this that aren't explained, what is 224? Where did I get that? Well, we're going to see that in a later video when we pick out a machine learning model that we can use. And so a lot of machine learning is lining up the size of your inputs or the shape of your inputs, in our case images, with the model that you're using. Again, we'll cover this later on, but essentially we're making sure that our images that we feed into a machine learning model are of this shape, so 224 high, 224 wide, because that is what the machine learning model that we're going to use was trained on. Images in that same shape. Remember how it's important to feed data in the same format and shape to your machine learning model as it was trained on when you're trying to make predictions. But we'll see that in practice later on. But let's write this function. So create a function for pre-processing images. So I'm going to call this nice and simple, process image. It's going to take an image path as input. And little docstring could be takes an image file path and turns the image into a tensor. Something simple like that. We could make it a little bit more intuitive later on, but to begin with, that's enough to explain it for ourselves. So we want to read in an image file, and to do that, we'll save it to a variable called image. And if we read through loading images, now you can do this for other types of data too, right? There's text data there, there's pandas data frame, numpy CSV. But reading through there, we see that we can go tf.io for input output, read file. There we go. What's this say? Reads and outputs the entire contents of the input file name. Well, that makes sense. Returns a tensor of type string. Beautiful. Let's do image path, but don't take my word for it. What we'll do is, and I want you to adopt this practice too. If you ever see a function that you're not entirely sure of what it does, rewrite it line by line. So let's check this out. We'll go tensor equals tf.io read file, and then we need an image path, so we'll do file names. I'm 26, so we'll get file names 26. And what's that look like? Oh, so it's shape of a string. And then a whole bunch of characters I don't understand. But that's an alright thing because the computer understands them better than I do. So what it's done is it just taken the file name and turned the contents into this long tensor. Wonderful. So the next step, use TensorFlow to read the file, save it to image. Yep. Turn our image, a JPEG, into tensors. Okay, so let's do that. Turn the JPEG image into numerical tensor with 3 color channels. Red, green, blue. And again, checking out the loading images documentation. So we're reusing this variable here. Now we're going to reset it to be tf.image.decode. See how we've got some options here? We've got PNG, which is a type of image file. We're going to use JPEG because our images are in JPEG. Image, and then we pass it the variable channels. The ATA channels indicates the desired number of colored channels for the decoded image. In our case, we want 3 for red, green, and blue. Beautiful. Now, again, if we wanted to check out exactly what this is doing, let's take tensor and go tf.image.decode JPEG. We'll take tensor and then we'll go channels equals 3. Oh, look at that. You've got exactly the same sort of data as that we have up here. Wonderful. All right, now to save, in the interest of time, we're going to write a couple more lines in this function, but we won't go through these similar steps. That's what I want you to have some practice doing. If you do see a function and you're curious to what it does, try writing it out line by line and see what happens. So you're just going to have to trust me with what these lines do. So convert the color channel value. So this is called normalization. I'll write the code first and then tell you about it. From 0 to 255 to 0 to 1 values. So we want to go image equals tf.image convert image dtype image tf float 32. Now, what's the docstring say here? Convert image to dtype, scaling its values if needed. Images that are represented using floating point values are expected to have values in the range 0, 1. Wonderful. Now, you might be thinking, how do you know this, Daniel? How do you know that you have to convert it from 0 to 255 to between 0 and 1? Well, actually, I lied. I said we weren't going to look at that, but this is a good one to investigate. Tensor, just so you can see, we've got values there between 0 and 255, and now I'll run this. Oh, no, I don't actually want that. Messing myself up here. We'll rerun this, rerun this. So I just want to demonstrate what this is doing. So image, convert. So basically all it's doing is it converts our values, it scales them. Instead of being between 0 and 255, they now are between 0 and 1 with the same scale. Float 32. Oh. tf.float 32. Wonderful. So we've got the same shape, but now instead of being between 0 and 255, they're between 0 and 1. And now this type of process makes computing on these more efficient. That's the most you need to know. It's called normalization. And again, this is just straight from the loading images documentation. Now what do we have to do? Actually, I don't think we had a step here for that. We might have to put in for normalize our image, convert color channel values from 0 to 255 to 0 to 1. There you go, 5, 6. Okay. Now finally, we can resize the image. Now by now, I believe you trust me in what this line is going to do, so we're not going to type it out. I'm going to leave that to you. 224, 224, so basically a square. Exactly a square, actually. Image.resize. Resizes images to size using the specified method, okay? And now we want to resize image, and the size is going to be height, width. Now you see why we define this here. Maybe that if we wrote this function a bit better, we could input image size as image size. That's probably a little bit better. Wonderful. And now you'll get this kind of practice as you start to write your own functions. The first time you write a function, it'll probably be pretty bad, pretty terrible. But then as you start to work out what your workflow is, you'll start to understand how to write a better function. Now, we can return the image. So what has this done? Has it done exactly what we just said? It takes an image path and an image size. We can define that here. It reads in the image file from the path name, beautiful. It turns the JPEG into numerical tensor, so we're just converting it to a tensor with 3 color channels, red, green, and blue, because that's the convention for most deep learning image models. They want red, I said read. Not that that's a bad thing. Reading is a great thing. We've then converted the color channels from 0 to 255 to 0 to 1 values. And we finally resized the image to our desired value. Now, we've written this in a function. So the beautiful thing is that we can use this later on. This is what I used to do, right? I used to run through these lines of code every time I wanted to process an image. Terrible workflow. So we can actually remove these. Remember, if you want to check out what the function is actually doing, break it down line by line. Takes an image path as input and then see what the rest of it does. Now, I think that's enough for this video. We've got our function created, ready to pre-process some images. What we might do now is, again, if we were to read through the loading data in TensorFlow, I think it's this one, yeah. Back through here, there's a little section in here that TensorFlow likes to see things in the form of batches. So we'll figure what batches are in the next video.